So in analyze phase, what you are doing is you are analyzing data, the information which you measured in the measure phase. One of the important analysis which you can do in analyze phase is see the effect of one variable on another variable. For example, let's take a simple example of ice cream sale. So I have a shop where I'm selling ice creams, and now I want to study whether the sale of that ice cream depends on the weather, the temperature or not. So what I can do is I can do a study and find out whether the sale of my ice cream changes with the temperature outside or not. So what I'm doing here is I'm seeing the relationship between two variables, two things, and this is what you do in correlation and regression. So in correlation and regression, this thing can be put in the form of a formula which is y is equal to fx. That means y is the function of x, y is the output. So output is the function of inputs, and that's a common sense. Your output will depend on number of inputs. In this particular case, in the ice cream sale case, the input was the temperature. Outside temperature is the input, and the output of that is my ice cream sale. Similarly, if I take another example of studying and appearing in a test, how many hours I study and how many marks I got in that test. That could be one of the case where you can use correlation. So what I want to prove here is that how many number of hours I study, that will influence the marks which I obtain. So in this particular case, the y, which is the output, is the number of marks which I get in the test, and input is number of hours I study. So this is another case of correlation regression where you can find out the relationship between two things. So whatever project you are doing, you might want to evaluate whether one of the thing which you are studying is depending on other thing or not. That's where you can use the concept of correlation and regression. To understand this, let's take this simple example of numbers of hours studied and marks obtained. So what I did in this particular experiment is I interviewed 10 students and asked them how many hours they studied for the exam and what was their test score, and I recorded that. So the first student who studied for 20 hours got 40 marks in the exam. The second student who studied for 24 hours got 55% marks, and so on. Now I can see whether there is any relationship between these two things or not. Let's remember one thing here, that number of marks which student gets depends on number of hours. Yes, but that's not the only factor. There are number of other factors as well. So there might be a relationship between these two things, but that relationship would not be a perfect relationship. It's not that you study for 10 hours, you get 10 marks. You study for 20 hours, you get 20 marks. Your relationship will not be that strong. But still, the number of hours you study will influence the marks which you get in the exam. But then how do I see that? How do I check this? So the first thing which I might want to do is draw a scatter plot. So let's do that on the next slide. So here I have the scatter plot on the right, marks table on the left and the scatter plot on the right. Now on the x-axis I have put hours studied, and on y-axis I have put the marks obtained, and that's what we said earlier. Y is the output, output is the marks obtained, input is number of hours studied. And now I plot each of these 10 points on this particular scatter plot. Once I do that, I can generally see that there is a trend here. More number of hours studied will lead to more marks obtained. And then I can roughly put a line here as well, which I have done here with the help of a dotted line. So this dotted line could be roughly the line which can show the relationship between these two variables. So if all my points or the dots which I have, if all these are near to this line, then I can say that there is a strong relationship. But if these points are scattered around that line, then I can say that there is a weak relationship. Let me draw an example of a strong and weak relationship. So if this is my line and my points are very near to this line, then I can say that this is a strong relationship. The relationship is very strong between x and y. Whereas the weak relationship would be something like this. Points are increasing, but they are not very near to the line. So this is a weak relationship. Looking at this scatter plot, we can say that what sort of a relationship we have between these two variables. So this was one aspect. This was correlation. Here we looked at the relationship between two variables. We can find out a number also, the correlation coefficient, which we are not doing here, which we will be doing in green belt or black belt, but you can find a number also. That number can give you a good indication how much strong the relationship you have here. But for now, let's keep it to scatter plot. Just by visually looking at that, we can predict whether the relationship is strong or weak. So this was correlation. The next thing is regression. Regression is where you find out a formula or equation which you can use to predict something in future. So let's look at regression in the next video.